Okay, for this lab, we're going to be experimentally determining the value of R. This requires a single replacement reaction where magnesium is going to react with concentrated hydrochloric acid. The first step of our procedure is to get our concentrated hydrochloric acid into this eudiometer tube. Because vapors will come off of this concentrated HCl, we're doing this in the ventilation hood. In the very bottom of this eudiometer, I'm going to estimate and I'm going to put in about 8 milliliters of HCl. It can be a little bit more, a little bit less, and then I'm going to top it off with some distilled water to give it a barrier between our thumb and when we invert it into the battery jar later in the procedure. And usually this takes a few pipettes full of the HCl. It'll spill just a little bit, but that's okay. We can clean it up with baking soda later in the procedure. I'm gonna add a few pipettes full of this until I get to about 8. Looks like I'm there right now. The last step is I'm gonna start to fill this slowly with distilled water so that there's a barrier between the HCl and my thumb. I'm at the point now where I've filled this eudiometer up to about the halfway mark, and I'm going to clamp this eudiometer tube in the upright position so that it doesn't go anywhere by turning the nuts clockwise. We're at the point now where we're ready to use some copper wire to anchor our piece of magnesium into the eudiometer tube. What we essentially did was we took a piece of copper wire and we twisted it into a loop so that the magnesium is sitting on the edge of that loop, and we can twist the edges of the copper wire around the lip of the eudiometer. What I'm going to do is I'm going to make sure that my magnesium is securely inside of the eudiometer, inside that loop, and then I'm just going to very carefully take the copper and bend it around the edges or the lip of that eudiometer, and that should, for all intents and purposes, keep this in place when I invert it with my thumb. Our final step is going to be to fill the eudiometer all the way to the top to make sure that there aren't any air bubbles that could affect our final volume of hydrogen gas that we're going to collect. This is all going to happen very fast, so it might be helpful to have somebody else in your lab group help move the battery jar while you're actually doing this part of the procedure. I'm going to carefully fill my eudiometer up to the top, and you'll see the hydrochloric acid starting to swirl there towards the bottom of the eudiometer. And now we're ready to start our process of inverting it. I'm going to cap the bottom, set it carefully in the battery jar, and you'll see bubbles of hydrogen gas starting to form. Those bubbles will start to travel up the top of the eudiometer, and we'll start to see some of this reaction. So we'll try to catch a quick clip here after it starts to react. Did you cut it? We're at the point now where the reaction has picked up pace. You can start to see a lot more bubbles that are starting to form in the eudiometer, and if you watch very carefully here at the top, as the eudiometer begins to fill with hydrogen gas, the meniscus of that water will begin to drop based on the amount of volume that hydrogen gas is starting to displace. As the reaction starts to go faster and faster, you'll see the level of the liquid at the top of the eudiometer begin to drop faster and faster until it doesn't drop anymore. And that's the point we want to wait for, is when this reaction fully proceeds. Our reaction is over, and we're actually trying to find what the final volume is of that hydrogen gas. If I look at my meniscus, I can very quickly read that, and it looks like it's about 95.4. But your value that you're provided will be a little bit different than the one that we have recorded here in the video. Now, there is something that we should do if the level of the meniscus is not exactly at the level of the water. We have to measure in millimeters how far above the level of the liquid the meniscus is. And it looks to be approximately 1 centimeter, maybe about 0.9 centimeters. 0.90 if I'm carrying my decimals out to the right number of decimal places. And then I'm going to use that as a correction factor to correct for the pressure of that difference in the level of the liquids.